Imagine a bright, sunny day with the sun shining at its peak, enveloping everything in a dazzling light. As the hours pass, the sunlight gradually weakens until nightfall arrives, bringing with it a pitch-black darkness. But why does space, adorned with countless cosmic light sources, appear so gloomy to us during the night? In this video, we will explore the reasons behind the darkness of the night sky and the mysteries of the universe. Don't forget to subscribe and hit the notification bell to never miss any of our fascinating videos. If you enjoy our cosmic explorations, give us a thumbs up. The Albers Paradox. Our planet takes 24 hours to complete one rotation on its axis, causing the sun to appear to move across the sky during the day. However, once the sun sets and disappears from view, we are left with a dark firmament. Johann Kepler, a German astronomer, observed this darkness and questioned the assumption of an infinitely large universe with a uniform distribution of stars. This enigma, known as the Albers Paradox, captivated the scientific community for decades. Heinrich Wilhelm Olbers and the absorption of light. Heinrich Wilhelm Olbers proposed an explanation for the darkness of space by suggesting that the gases between stars absorb the emitted light. This would reconcile the concept of an infinitely large universe with the absence of a brightly lit night sky. However, Olbers's assumption was flawed. If starlight reached the gas, it would heat up and emit its own light. Eventually, astronomers discovered that the nebulae observed in the firmament were distant galaxies, debunking the idea of an empty void beyond our Milky Way. Non-uniform distribution of stars. Contrary to the assumption of a uniform distribution of stars, celestial bodies actually cluster together in galaxies and form larger galactic structures. While the basic cosmological principle remains intact, stating that every direction should eventually lead to a star's light reaching Earth, the vast distances between our planet and these glistening stars make their light almost imperceptible. The gigantic scale of space. The average distance between Earth and the stars is unimaginably large. It is quantified as 10 to the power of 23 or 100 trillion light-years. A light-year is the distance light travels in 1 year, covering about 6 trillion miles. Therefore, the light emitted by an average star takes an incomprehensible amount of time to reach our planet. Considering the universe formed approximately 13.8 billion years ago, the observable portion is still too small to create a brightly lit night sky. The finite nature of stars. Stars are not eternal. Their nuclear reactions only last for a relatively short time. Even if we were to reach a future point where we could observe a larger portion of the cosmos, most stars would have already burned out. As a result, the night sky will never be accompanied by a dazzling brightness in the distant future. Cosmic microwave background radiation. Although the night sky appears dark to our eyes, it is not entirely devoid of radiation. The Earth is constantly bombarded by a weak, uniform radiation from all directions. This radiation, known as the cosmic microwave background, is a remnant of the Big Bang. Approximately 380,000 years after the birth of the universe, when its temperature dropped to around 5,400 degrees Fahrenheit, stable hydrogen atoms formed, making the cosmos permeable to electromagnetic radiation. However, this radiation has gradually lost its intensity over time and shifted into the microwave range, making it invisible to our eyes. Limited human perception. Our human eyes can only perceive a fraction of the entire light spectrum. If we were able to see in the infrared and microwave ranges, the universe would appear drastically different. Scientists estimate that the visible baryonic matter represents just 4.9% of the total matter in the universe. The rest consists of hypothetical dark matter and dark energy, which play significant roles in galactic processes and the accelerated expansion of the universe. Conclusion. The darkness of space during the night hours is a result of various factors, including the non-uniform distribution of stars, the enormous scale of the universe, the finite nature of stars, and the shifting of radiation into the microwave range. While our eyes perceive darkness, space is filled with weak uniform radiation, and the hidden mysteries of dark matter and dark energy await further exploration. Thank you for joining us on this enlightening journey through the cosmos. Share your thoughts and suggestions in the comments and be sure to check out our other captivating videos.